Beatriz Villarroel. Now, unfortunately, Dr. Beatriz was unfortunately taken ill earlier this week, and so she's had to do her presentation electronically. We are now going to see her paper. She has been very heavily in the news this week because she has some pre-published research, is that the correct term? Pre-published research that's been quite controversial. You are seeing it here tonight.
Hello, everyone. Thank you a lot for inviting me here. I'm really sorry I couldn't come in person, but I'm so happy that I have a chance to talk to you even virtually. So I'm going to present my research. And as some of you may know, my research area is SETI, Searches for Extraterrestrial Intelligence, and in particular, the near-Earth SETI, where I look for alien artifacts in the solar system. So why should we care about looking for life in the Milky Way? Well, the Milky Way is big. You have 200 to 300 billions of stars just in our own galaxy. And many of our sun-like stars do actually have an Earth-sized planet. Like 22% of all stars that look like the sun in the Milky Way have a planet that is kind of Earth-sized and in the habitable zone. You can estimate that there's something between 20 to 40 billion of Earth-like planets just in our own galaxy, so it's quite many. Also, amino acids have been found on asteroids and meteorites, and the basic nucleotides have also been found on meteorites. There's great chance that there's lots of life in our galaxy. Taking it to the other topic, the topic of UAPs, astronomers have observed UAPs for hundreds of years. Take Charles Messier. He actually saw large dark objects during a lunar eclipse that didn't look like meteors, and they looked like they had organized movement. I can't promise he didn't see birds. Anyway, also a survey done in 1992 among the astronomers in the American Astronomical Society showed that 62 out of 1,356 astronomers had seen a UFO. There's a wonderful book by Jacques Vallée that discusses observations done by scientists. One more recent thing that many of you have heard about, I'm sure, is the detection of the biosignature DMS in a water world not far away from us. And this is a good detection. I know there has been a lot in the media trying to debunk it, but I still say, give it a chance, give it a few years. I think these guys are going to prove that there is life there. But that is my personal bet. Some people ask, of course, but how can it even be possible that someone sends a probe to the solar system? And then I say, oh, of course it is possible, because we humans can send probes. We humans have already sent some probes that have left the solar system. Why wouldn't another civilization be able to do the same with us? So one of the ways how we can explore all this is by ourselves look for probes. And we can use images from the sky before Sputnik, before the first human satellites, when there were no space trash in orbit. And we can use these images to search for probes or other kind of artificial objects. And there are wonderful photographic plate archives that we can use for this purpose. They act like a time machine. So in order to do so, and to distinguish them from all kind of unusual plate defects, some people think that there are plate defects that look like stars and by coincidence just have a star-like brightness profiles. And in order to kind of separate these cases, one might choose to look for certain features. For example, one might choose to look for those that are like these short light flashes that fall on a line, like you see here. That's one of the ways of looking for ET probes. One can also look for just multiple flashes, or one can look for like triple flashes. And there are different kind of signatures that we can expect. And how would we look for these things? How would we look for these kind of signatures? Well, one can use images from the Palomar survey that use these 6 by 6 degrees large heavy glass plates in the early 1950s, before the first human satellite was launched. And one can compare these images to the sky as it looks in Pan-STARRS in the 2015. And taking these two giant data sets, one can search for everything that existed in the Palomar that no longer can be found in the Pan-STARRS. And of course, then I don't talk about you going there and looking at the glass plates, but luckily, these plates have been digitized. So we can use the digital scans to search for these transients. And what I'm mostly interested in is to look for reflections or emissions from non-human satellites. If you especially have this kind of artificial objects that have a very flat surface that is extremely reflective and in a high altitude, you can actually expect to see fast flashes that last shorter than a second or just a second. And these fast flashes will look like a little star on the plate and never be seen again because they are so short-lived. And that is what I'm interested to look for. Here are some examples of what we actually have found. You can see here a triple transient. It was found by my colleague Enrique Solano at the Spanish Virtual Observatory. And it's a beautiful, like 3-star, it's a beautiful image of 3 stars, very bright, that are seen there on 19th of July, 1952, and never seen again. You compare to images half an hour before, years after, and months after, and you never see it otherwise. It's there very shortly. It was published in the monthly notices of the Royal Astronomical Society in 2023. Another such example is this one, where you can see 4 transients along a line and 2 more there. It's seen there on the 5th of August, 1954. It has a probability of 0.003, and you never see it again, but there are the 4 along a line. Here's my favorite. You can see 5 that are aligned along a narrow band. Not exactly like you expect satellites, maybe more like a formation. The probability for this alignment in this image is 1 in 10,000, and it happens on 27th of July, 1952. Now, the funny thing that you might not have noticed is that one of this example was from 19th of July, 1952, and the other example is from the 27th of July, 1952. And we actually first wrote the papers, posted one on the archive, got the other like submitted when we noticed that the 2 examples are happening, each one from 2 consecutive weekends of the most famous UFO mass sighting through history, the Washington, D.C. 1952 UFO flap. And this was a date when there were lots of flying saucers seen. There were a lot of high quality testimonies about UFO sightings. Radar operators saw a lot of weird objects on their radars when they were at the national airport. Pilots saw a lot of objects. There was even fighter jets sent out to hunt for these weird objects. And by chance, our most interesting candidates are from each of these 2 weekends when there were so many UFO flyovers. Of course, this led my colleague Steve and myself to ask the question, is there actually a correlation? Is there, maybe it's not just a coincidence, maybe there's a correlation in time between our transients and UFO reports. So we took images from or transients, a list of transients from 1949 to 1957 that are all before Sputnik 1. It's 110,000 Vasco transients. And he took data sets of nuclear test dates from Soviet, UK, British tests, and he took UFOs from the UFO catalog database. And he tried to see, is there any correlation? Well, actually, he did find correlations. Statistically significant correlation between the nuclear test and our transients, between the UFO report and our transients. and between the UFO report and the nuclear tests. This totally defies any idea of that these transients are some kind of dirty plate defects that are on the photographic plates, because there are many astronomers that they will not even want to look at the photographic plates, because they will say, oh, it has to be plate defects because these things contain lots of plate defects. No, this defies that. It says that a part of the population are likely something else, something physical. And it's also independent confirmation of the suspected correlations between transient and UFOs. Of course, correlation doesn't mean causation. We still don't know what it means. But I do suspect that the connection between UFOs, transients, and nukes points towards that the vascular transients are optical astronomical counterparts of UFO events. We just don't know about it yet. We have to test this. The correlations are anyway statistically significant and highly interesting. Another thing we did is that we did a test using the Earth's shadow, because again, we have the people who want to believe that maybe these transients are just plate defects, but then they will be anywhere on a photographic plate, it doesn't matter. However, if you think that these transients are due to sunlight reflection on something flat and highly artificial at 42,000 kilometers, then you expect that they will not be seen in the Earth's shadow. Because if you have no sunlight, you cannot cause that solar reflection. So we actually tested this. You can calculate for each transient whether it's inside the Earth's shadow or not. And the Earth's shadow casts this cone, and at 42,000 kilometers, it's something like 8-9 degrees in radius. And you can calculate the number of transients inside the Earth's shadow. And what you actually do find is a really strong, very strongly significant deficit in the Earth's shadow. There are 30% fewer of transients inside the Earth's shadow, which should suggest that a significant part of our sample of the transients are actually reflective objects in orbit around the Earth. And it totally defies, of course, the idea of that you have some kind of plate defects. Yes, so I'm coming to an end of my talk. So where do we want to go from now? Well, first we need to confirm and replicate these findings with other plate archives. We need to see that this really can be seen also in other photographic plate archives like those from the Vatican. But also, what we are going to do is try to see if we can find something in the modern sky. And to do that, we have a project called ExoPro, where we try to build a network of telescopes to search for, detect, validate, localize such a transient, where from it comes, and eventually get a spectra of it. And this is where I'm now. I want to use this system. I want to build it up. I want to have more telescopes. Currently, we have one telescope and we need at least 2 or 3. And I want to search the modern sky for UFOs and trying to get rid of all the space trash while we do that. It's not going to be easy, but I think it's really important that we do this because we need answers. Are we alone? Thank you.
Okay, thank you very much indeed. In a sense here, if we can thank Dr. Beatriz. Okay, thank you very much indeed.